Hello, Sam.
Hi, Amina.
I've heard you're really good in math. Could you explain me what correlations are, please?
Of course. What do you know about correlations so far?
It describes the extent to which two variables are linearly related.
Yes, Amina, that's correct. So, basically it means how both of the variables are changing together. Let's look at an example. Let's have a look at these four charts. When we look at chart 1, we see that whenever x is rising, y is rising as well. This will be even more obvious when we add a trend line. In this case, we call it a positive correlation. On the other hand, when we look at chart 2, we see that an increase in x is causing a decrease in y. This is called a negative correlation or anti-correlation. How do you think x and y are correlated with each other in chart 3?
Looking at the chart, I can see that when x is rising, y is staying at a similar level. So, I guess they are not correlated with each other?
Yes, correct. X is not correlated with y. But, what about chart 4? Do you mind taking a guess too?
That's a tough one. I don't want to guess wrong. How can we find the correlation between x and y in this example?
Well, we could look into the math behind correlations and apply it to the points in the chart.
Sounds great. Let's do it.
First of all, we should extract the data points from the coordinate system into a table. Then we should take a look at the formula for the correlation coefficient.
Wow, it looks kinda complicated.
Don't worry about it. We'll break it down piece by piece.
Awesome.
The numerator is the covariance. The covariance is a measure of how two random variables are related to each other. A positive covariance means that the two variables are moving in the same direction. A negative covariance means that they are inversely related and move in opposite directions.
Wait. That sounds just like the correlation. So are covariances and correlations the same thing?
No, even though their description is similar, they are not regarded the same thing, because the correlation is also showing the degree to which both variables are moving together. Continuing with the denominator. The denominator is the product of the standard deviation of x and the standard deviation of y. The standard deviation describes how far the variables spread from the mean. In the formula, you can also see some variables with a little bar on top. These lines indicate the mean of x and y. We can often find the mean of x and y in the formula, so it'd be great to start with them. To calculate the mean of x, we sum up all of the values in x and divide the sum by the number of entries. For the sum of x, we get 27, and there are 10 entries in x, which gives us a mean of 2.7. Repeating the same for y, we get a sum of 24. Again, we have 10 entries, resulting in a mean of y equaling 2.4. After calculating the mean of x and y, we can continue calculating the numerator. We take the first data point with x equaling 1.0 and y equaling 1.0. We subtract the mean of x, do the same for y, and then multiply the two resulting numbers. We repeat this step for all data points in our table and then take the sum. Here the result is minus 1.8. Next we calculate the standard deviations for x and y. The standard deviation of x is 4.31277 and the standard deviation of y is 4.78539. Now we combine everything and therefore divide minus 1.8 by the product of 4.31277 and 4.78539, and we get a correlation coefficient of minus 0.08722.
Great, but what is this value telling us?
The short answer, x has a very low correlation with y. But to better understand, it is essential to know that the correlation coefficient is always in a range of minus 1 and 1. Let's have a look at the following chart. Here we can see the closer the value is to minus 1 or 1, the stronger the anticorrelation or correlation. Conversely, a correlation coefficient close to 0 shows a weak correlation between x and y. Just out of curiosity, why do you want to learn about correlations?
Oh, I recently looked into trading stocks and while reading about it, I came across the correlations.
I see. However, here you need to be a bit careful. While the correlations show how two variables covary, they have neither a direct nor indirect causal link. Not having a causal link means a change in one variable is not causing a change in the other variable. Nevertheless, correlations can be a valuable tool to diversify your overall investments.
Ah, I understand. By diversification, do you mean that when I have stocks from companies A, B, and C, which are all highly correlated, I should buy stocks from company D, which are anti-correlated to my current stocks? So, when companies A, B, and C move in one direction, hopefully, my stocks from company D will not move at all or even move in the opposite direction.
Exactly. But also, be wary that there's no guarantee this will save you 100% of the times of possible losses. So, as always in trading, trade at your own risk. If you want to see the correlations between different stocks and even cryptos or forex pairs, check out www.financeofficial.com.